This is Sharma solution, class 12th, chapter 6, Determinants. Exercise is 6.3. Now this exercise, this is basically based on the area of the triangle using the determinants. So there are various methods to find out the area of triangle. We have seen in coordinate geometry, we have seen in triangles. But here the area will be found out using the triangle. So the first one I am going to tell you properly and others will follow. And in the later questions also we'll see wherever the discussion is mandatory, I'll discuss it. Okay, this is x1, y1. This is the vertex. x2, y2 is the vertex and x3, y3. These are the three vertices of a triangle. The area of the triangle is half. Now you have to take the x coordinates in the first column, x1, x2, x3 like this. Then you have to take the coordinates of y coordinates in the second column, and then you have to place 1, 1, 1 in the third column. So this is the area of the triangle. So the basis of solving this is the last column we will make two zeros. For example, this first example I am going to take x1, y1, x2, y2, x3, y3. You can take any of these as x1, y1, x2, y2, x3, y3. So according to the formula, we have half. In place of x1, x2, x3, 3, negative 4 and 5 I am writing. In place of y1, y2, y3, I am putting 8, 2 and minus 1 and 1, 1, 1. Now if you see any other thing, like properties can be applied, but here the simple thing is R2 minus R1 and R3 minus R1. Means row 2 needs to be changed to row 2 minus row 1 and row 3 needs to be changed to row 3 minus row 1. We have seen in the determinant solution also that this is what we have to do. So row 1 will remain intact, 3, 8, 1. So minus 4 minus 3 is minus 7, 2 minus 8 is minus 6, 1 minus 1 is 0. Similarly, R3 is R3 minus R1. So 5 minus this 5 minus 3 we are doing. So 2 this minus 1 minus 8 is minus 9 and 1 minus 1 is 0. Now we will open it using the first column. And what will be the sign? This is A13, this is A23 and A33. So it will be plus minus plus, because minus 1 to the power 4, minus 1 to the power 5 and minus 1 to the power 6 it will be. And minus 1 to the power odd is negative, minus 1 to the power even is positive. So first last column we are opening, and we'll just take 1 because eventually 0, 0 it will give 0. So 1 minus 0 into plus 0 into something. Okay, so let us take 1 of this. So minus 7, 2, minus 6 and minus 9. So minus 7 minus 9 is 7 is 63. And then we have minus will become plus 12. So this is 5 and 7. Now this is half of 75. 75 by 2 is the answer. You can divide also and write, but it has to be in the square units, because area always comes in the square units. 75 by 2. You can write it in decimals also. Now all these other parts, 3 parts, has to be done exactly like this. I'll just give you a glimpse of it. If you're able to solve, or if you're trying to solve and you're stuck, you can just take a reference here, visit here and see if the things are going well or not. So this is the fourth part here. Exactly same criteria, way, method, logic has to be applied. Now the second question is, using determinants, show that following points are collinear. So the concept here is that collinear means if you want to have an area of triangle half x1, x2, x3, y1, y2, y3, 1, 1, 1, x1, y, x, y are the coordinates of the 3 vertices. Now when you take a triangle and then these vertices, they are not in same line. That is why we have area. But if these 3 points are in the same line, then the area of the triangle is 0. So we'll take these 3 points, try to find out the area. if the area becomes 0, that means that these points are, or these vertices are collinear. So let us take the first one, others will be followed, it means has to be done like this only. So half into x1 is 5, x2 is minus 5 and x3 is 10. This one and this one we have taken. Now y1, y2, y3, 5, 1 and 7. So 5, 1 and 7 and 1, 1, 1. Okay. So half will take later, but let us see here. The basic thing is row 2 to be changed as row 2 minus row 1 and row 3 has to be changed as row 3 minus row 1. So 5, 5, 1, minus 5 is minus 5 minus 10, 1 minus 5 is minus 4 and 1 minus 1 is 0. 10 minus 5 is 5, 7 minus 5 2, 1 minus 1 is 0. So we will open it using the third column, 1 into minus 0 and plus 0. So what do you get? This is minus 10, minus 4, 5 and 2. So minus 20, minus plus, 5 4s are 20. So 20 plus 20 minus 20 is 0. So now the area of the triangle is 0. That means these 3 points are collinear. They are on the same line. The area of the triangle is 0. So next one is like this. So just have a look if you are solving it. So this is the fourth one. So it will be 0, then means it is a collinear. If points A0, 0B, 1, 1 are collinear, prove that A plus B equals AB. Collinear means they are on the same line. Triangle area should be 0. So we'll try to find out the triangle area. Half x1, x2, x3 is A0, 1. y1, y2, y3 is 0, b1, 0, b1 and this 1, 1, 1. So when we try to find out the area of the triangle, it has to come 0. So we have to equate it to 0. So if you multiply both sides by 2, it will be 0 only. So half can be cancelled. Basically, R2 minus R1, you have to change R2, row 2 to row 2 minus row 1 and row 3 has to be changed to row 3 minus row 1. Okay. So let us see here. This is row 2, R1. So R2 minus R1 will be A01 will be like that only. 0 minus A is minus A, B minus 0 is B, 1 minus 1 is 0. Then we have R3 minus R1. This gives you 1 minus A, 1 minus 0 is 1 and 1 minus 1 is 0. Okay. So half, as I said, half can be multiplied by, both sides can be multiplied by 2. It will be this determinant only. So we are opening it using the third column. 1 minus A, 1 minus A, B and 1, this is equal to 0. Other will be, I am not taking others, it will be 0. Minus A minus B, 1 minus A equals 0. Minus A minus B plus A plus AB equals 0. So AB equals A plus B. So this is what we have to prove and we have proven it also. Using determinants, prove that the points A, B, A dash, B dash, A minus A dash, B minus B dash, these are collinear. If A, B dash equals A dash, B. So this is the collinearity condition, but we also know the collinearity condition is the area of the triangle has to be 0. Mostly when we have alpha, beta, gamma or A dash, B dash, the main thing is there are chances of computational errors. So you need to be very attentive solving this kind of question. So half, you have A dash and A minus A dash. Then you have B dash and B minus B dash. 1, 1, 1. Okay. So what we'll do, we'll place it to equal to 0. So R2 minus R1 you have to do first and R3 minus R1 you have to do. Row 2 minus row 1, row 3 minus row 1. Half doesn't matter because if you multiply both sides by 2, it will be goner. So let us see. So you have to write exactly what I am showing you in the printed area. So we have A minus R2 minus R1 is A dash minus A, B dash minus B, and 1 minus 1 is 0. So A dash minus A, B dash minus B, and 1 minus 1 is 0. Let me write the first row also, A, B, 1. What about this R3 minus R1? So A minus A dash minus A. Let me write it here, A minus A dash minus A. This will be negative A dash. B minus B dash minus B dash. 1 minus 1 is 0. Okay. Now this column we are opening. 1, you get A dash minus A dash, B dash minus B dash. Okay. So this is going to be 0, equal to 0. Okay. So let us cross multiply here. And what do you get? So I am not writing step by step, I am just giving you the logic. So A dash minus A into minus B dash, then minus plus A dash, B dash minus B equals 0. This is minus B dash A dash plus A B dash plus A dash B dash minus A dash B equals 0. So these two gets cancelled. So take negative on the right hand side, A B dash is equal to A dash B. And this is what we wanted. This is your answer. Find the value of lambda so that these points are collinear. Okay, I'll tell you here only because this kind of question we have just done. So we will take 1 minus 4 lambda here, minus 5, 5, 7 will come here, 1, 1, 1 will come here. We have to just show that the area of the triangle is 0. Row 2 minus row 1 will do, row 3 minus row 1 will do, and whichever comes, lambda will be equal to negative 5. Okay. Find the value of x if the area of the triangle is 35 square centimeters with vertices. So we have half x, 2, 5. These three have taken the x coordinates. Now let us take the y coordinates. It will be 4, negative 6 and 4, 1, 1, 1 will be there. This equals 0. Oh no, this is equal to 35, sorry, because it is already given. 35 square centimeter. So let us do this row 2 minus row 1 and row 3 minus row 1. This is what we generally do. X 4 1. X 4 1 is the, so x 2 5, 4 minus 4 6, 5 4 minus 4 6 4. So it is 2 minus 6 minus 4, 1 minus 1 is 0. Now the row 3 minus row 1. So 5 minus 6 it will be 1 minus 4 is 0, 1 minus 1 is 0. So this is equal to 35 into 2, 70. Okay, now just open using the third column and just equate it. So there is just different discussion we have to do here. Let us just solve it and then you will see what it is going to be. Because area of the triangle can never be negative. That is why when we solve this, I am opening it using the third column. 2 minus x into 0, my 5 minus x minus 10, 0 into plus 0 plus 10 minus 10 into 5 minus x is 6 is 70. And this. Now the area of the triangle can be positive and negative. It is always positive. Sometimes the area can come also in negative, but normally we take in positive. So just assuming that this area of the triangle is plus minus. Please remember. So 50 minus 10x is equal to 70 in one case, and 50 minus 10x equals negative 70 in another case. Basically it is plus and minus 35, but we have just multiplied by 2. That is why I am saying 70 minus 70. Otherwise it has to be 35. Okay, 10. So I am taking first one. So 50 minus 10x equals 70. So 10x becomes minus 20, x becomes minus 2. This is from the one aspect. The second aspect, when we take negative, this 10x will be equal to 50 plus 70, that is 120. So x will be equal to 12. So x is 12 and x equals minus 2. Both are the answers. Okay. So for example, this is the area. Now we don't subtract them, we actually add them. And sometimes when it is in the, in different quadrants, sometimes it may be negatively assigned. but we have to take it positive. Area is always a number.